This meeting is being recorded.
Okay, this is our presentation of sea farming.
We are the Bluebonnet engineers, and we are from the Ann Richards School for Young Women Leaders. These are our team roles. We assign these roles based on each of the individual strengths that we bring. KK is visually creative and realistic. Ida is knowledgeable. Lily is innovative. And Stella is clever and technical. We discuss and collaborate for ideas, then work on our individual strengths. KK built a prototype and created the beautiful images on our slideshow. Lily researched and designed. Ida created the app with help from our contact/advisor, Evie, and Stella wrote numerous papers and coordinated.
Okay. The problem which we are combating is habitat loss and degradation. This is the destruction and loss of habitat and its quality. It can be outright annihilation or be caused by various harms such as pollution, invasive species, and more. Whatever the form, habitat loss and degradation harms and destroys native organisms, ecosystems, and biodiversity in the environment, and brings a large loss of life. It is the leading cause of the biodiversity crisis, anthropogenic extinction, and population declines. It continues at a disastrous rate. Agricultural land use is a large cause of habitat loss and degradation, so we chose that as our focus.
Our solution is the Ecobot, an adaptable irrigation system and app that implements sustainable land use through sea farming. C stands for sustainable, eco-friendly, efficient farming. Our original idea is that sustainable land use can build native habitat. If we use land in natural and eco-friendly ways, it can function as habitat and support biodiversity as well as being used by humans. This benefits the surrounding environment and counteracts habitat loss. We built the Ecobot to help users implement sustainable land use with irrigation. The purpose of our design is to help users do just that as a way to support biodiversity and make a positive impact in the world. Land can be used for both humans and for native habitat. Our innovation allows individuals to effectively make this happen.
The Ecobot is a mobile irrigation system that uses rainwater, solar power, and an app we designed. It functions as a sustainable drip irrigation system made out of a single section of pipe that is fixed to a moving frame. The Ecobot can move around and lower the pipe tray to irrigate a section. The frame holds a water tank which can be filled with rainwater and a robotic electric valve interface to communicate and control the flow of water. Though gravity moves the water, a robot bit also runs the wheels, positioning and settings of the Ecobot, and the lead screw which raises and lowers the pipe tray. It is a mobile, independent, and adaptable, making it effective for users. The Ecobot can be calibrated and controlled by the user to sustainably irrigate and can be used for agriculture or habitat restoration. The app guides users and gives information about sea farming practices and how to use your land more sustainably while integrating native plants, cover crops, and crop rotation. The app also gives users information about the Ecobot, how it works, and the importance of using land sustainably.
So now we'd like to show you the prototype that we currently have of the Ecobot. So should we move this down?
Sure.
No. It might look a little weird on Zoom. Hello. So as you can see, this is the frame. It's made out of aluminum extrusions. Recycled from a 3D printer. We also have this recycled tank that feeds water to this irrigation tray. We have yet to drill the holes, but the water will come out from here. So this can raise and lower the tray to irrigate a section, as you just saw, using this lead screw, which is powered by this motor and this robot bit. The wheels are using brush motors and are controlled by this robot bit, making the frame independent of any fixed point and able to move around independently. So how it will work is it will move over a row of plants, raise and lower the pipe tray, irrigate using the water from this tank over to this irrigation tray, then raise it and move again.
We started with just the idea of improving land use in agriculture with an irrigation system. Then we specified ideas to make our system unique, so it was distinct. Solar power and rainwater, so it was efficient throughout, and app control and calibration, with the application also providing information for sustainable farming. Next, we formed our core idea of seed farming and began creating the app. We made a prototype that used solar panels to power a pump. Then, during research for irrigation system and water physics, we created a concept of a portable system that can be calibrated and used in a guided, natural, and sustainable manner, which would make it unique.
On iteration 1, the solar panels power a pump, which moves water through a tube. However, the solar panels did not provide enough power and were unreliable. Because the holes were evenly spaced, the tube let out all the water at the beginning and no water out near the end of the tube. On iteration 2, we used a bigger solar panel and we put the solar panels in a chain to gradually increase power to fuel the pump. We also put fewer holes in the pipe at the beginning and more holes at the end to make the flow more even. However, with this prototype, there were numerous downsides, like how it was small, not portable, and not very easy to use. So on iteration 3, we made our design more portable and more user-friendly so that it can be programmed to water at specific times. We used the engineering design process to find a problem, which was wasting of water, energy, food, and land through bad agricultural practices. Then we went through a variety of ideas to find our solution. Our solution was C, farming, which involves the Ecobot and app. We found that these solution through several different rounds of brainstorming and research best fit the problems that we wanted to solve. Then our formal research process began. We used many sources to find the best methods and materials to construct our project and to find information for educating people through our app. We tested our second iteration, brainstormed, researched, and redesigned it for a more specific purpose in iteration 3. Revised the design in iteration 4 by changing the angle of the pipe supports so they were parallel. After that, we started constructing our project. We moved to iteration 5 with a lead screw, extrusion frame, wheels, robot bit, and we also began designing our app using several different app designers and finding the one that worked optimally. The engineering design process helped us to do it all and in this organized information.
So we also used experts to refine our design throughout the process. Our first expert is Jason Patman. Jason Patman is a certified permaculture teacher. He is currently working as a general contractor in the Central Texas area. By interviewing Jason, we gained insight into how to realistically create a design that can be used and purchased, and he gave us some light on what was possible and what was not. Our second researcher was Mr. Robert Lee. He's a retired engineer and STEM educator. He helped us by showing us other similar STEM projects. That helped us refine how is our project unique, what is its purpose, and how precisely does it work.
This is a build montage of our first iteration, which is powered by a pump directly.
Okay. This is our plan. Um, in, in the future, we plan on redesigning the system with improvements. We also plan on creating a 6th iteration prototype, as well as publishing the app and adding more information about the Ecobot on the app. The features that we plan on adding to iteration 6 are a separate solar power charging and rainwater collection apparatus, taller wheels, and specialized brackets. We also want people to be able to control watering schedules on the app. We also plan on possibly collaborating with a native plant company to make it easier for people to follow our seed farming practices and introduce native cover crops and trees into their farm, and to make it easier for people to find and purchase native plants and apply the sustainable farming practices we are teaching them about through the app.
In conclusion, our project
was inspired by a need for information and tools about sustainable agriculture. From this problem, we set forth to find a solution and educate people. Our design incorporates multiple elements that are new to us: app design, electronic engineering, and more. But we learned these skills and were able to create several iterations and prototypes. We worked as a team to overcome challenges, persevered, and ended up creating something that we are proud of.
Thank you so much for listening. We hope that you enjoyed our presentation about seed farming and the Ecobot. Thank you.